Hey there, welcome back to our channel. In today's tutorial, we're diving into the world of least squares regression. We'll be estimating the coefficients of a linear function and using them to predict values. But first, let's understand what least squares regression is. Least squares regression is a statistical method used to determine the best fit line through a set of data points. The best fit means that the line minimizes the sum of the squares of the vertical distances or residuals between the observed values and the values predicted by the line. This method helps us find the relationship between dependent and independent variables and is widely used in predictive modeling. Key points of least squares regression. Minimizes the sum of the squares of residuals. Finds the best fit line for a given set of data points. Helps determine the relationship between variables. Used in data analysis and predictive modeling. Here's our problem statement. In our case, we have a function that's linear in the parameters. Using least squares regression, we'll estimate these parameters to understand the relationship between x and y better. Here is dataset. Once we have those coefficients, we'll predict the values of y at x is equal to 2.5 and x is equal to 11. Let's start by clearing the command window and workspace using the CLC and clear all commands. Now we will define our given data where x represents the x values and y represents the corresponding y values. We need transforming of the x values by taking their natural logarithm, which we will store in the variable lnx. Then set up the design matrix X by combining a column of ones and the transformed ln x values. This matrix will be used for the regression. By using the least squares method, we calculate the regression coefficients by solving the normal equations. The resulted coefficients will be stored in the variable named coefficients. As coefficients represent the intercept and slope, we will extract the intercept term, a1, and the slope term, a2, from the coefficients array. Let's use print command to display the calculated coefficients in the command window. As a result, the intercept and the slope of the fitted equation will be displayed. Let's run the code to see the intercept and slope of the fitted equation. The command window shows the values of intercept and slope, which can be used to calculate y for any value of x. Let's use the intercept and slope values to calculate the y for two different values of x. Firstly, we will estimate value of y for x is equal to 2.5, and then we will estimate the value of y at x is equal to 11. Again, using the print statement to display the resulted values of y on the command window. Let's visualize the fitted curve to see if it passes through all the given data points. Creating a new figure with figure command. Plotting the original data points in red circles. Let's hold the plot for adding more curves on the plot. We can generate x values ranging from minimum to maximum values of given x vector. Utilizing the values slope and intercept a1 and a2, we can calculate the y values. Now plotting the fitted curve in blue on the same plot, we expect to see this curve passing through all the given data points. Now plot the estimated points in black. Let's add title. And label both horizontal and vertical axis. Adding a legend to differentiate two curves. Enabling the grid for better visualization. Let's release the hold so that next plot can replace previous one. It is observable from the graph that the fitted curve passes through all the data points given to us. In this way, using this intercept and slope, we can find the values of intermediate points that are unknown to us. Moreover, we can also predict the future values by extrapolating the I values for higher values of x. The command window shows predicted values of y for x is equal to 2.5 and x is equal to 11. Thus, using the curve fitting, we are able to estimate the intermediate values of the given data set. Now imagine we have a data of 10 days of daily average temperature, and we can use curve fitting to estimate the temperature at any hour within those 10 days. Isn't it interesting? If you enjoyed this tutorial, remember to like, comment, and subscribe. Thanks for watching.